So first one, let's call these A and B. A, probability all three are old, so that means that the first one will be old, second one is old, third one is old. Alright, in the first case you've got 3 old people out of 12, so the probability of picking the first one old is 3/12. Second case you've got 11 people left, 2 of which are old. Alright, so the probability of picking an old one on the second selection, given that the first is old, is 2/11. And then you have 10 employees left, of which one of those is old, so the probability of selecting an old one on the third choice, given that 2 old employees have been chosen in the previous 2 choices, is that, right? And again, whatever that probability is. Okay, and if my calculation is correct, that's 0.004545, etc. Okay, very tiny probability. So the probability of this supervisor randomly selecting the 3 old employees to fire is so small that it's unbelievable that he did not use age or something based on age to fire them. Alright, next one, probability 2 of the 3. 2 old and 3. Order is not specified here. So we have to worry about the orders. So, but the way around that is to use the number of ways times the probability of one way. How many ways are there getting 2 old and 3? Well, it's the same as the probability of 1 young in 3, and how many ways of getting 1 young? Well, you get young on the first, young on the second, young on the third, and so there are 3 ways of doing that times the probability of one way. Let's say just young, old, old. Alright, young on the first one we have 15 total employees, 12 young. At that point we have, sorry, alright, let's look at the answers for these now. Alright, probability all 3 are old, so there's a probability old on the first, old on the second, old on the third. It's just one way, so we don't have to go through the more complicated way of number of ways times the probability of one way, so this is just one way. Alright, we have 15 employees, 3 are old, so the probability of getting an old one on the first drawer is 3/15. The second drawer we have 14 employees left, of which 2 are old, so 2/14 on the second drawer. Given that the first drawer is an old person, and on the third drawer we have 13 employees, and now we just have 1 old, given that we have an old person drawn on the first and the second. So the probability of 1/13, given that we've already selected 2 old. And alright, and if you wish to calculate the answer for that, the answer is 0.002198. Very tiny probability. So the probability that the supervisor selected 3 employees, 3 old people at random without regard to their age or anything related to their age is so small that it's not going to happen very likely. Okay. Alright, second one is the probability of 2 of the 3 are old. Okay, so 2 old out of 3. Now we have to worry about number of ways times the probability of one way. How many ways are there? Well, 2 old out of 3 is the same as 1 young in the 3, and 1 young in the 3 is sort of easier to visualize. Picking 1 young out of 3 is just like 1 head out of 3. You get a young on the first, or a young on the second, or a young on the third. So there are 3 ways times the probability of one way. Let's just say young, old, old. Alright, young on the first, well, we have 12 out of 15 young on the first drawer. Old on the second drawer, we have 14 total, of which 3 are old at that point. And on the third drawer we have 13 left, of which 2 are old. Okay, and so the answer for that is, alright, the answer for that, have to calculate is 0.07912. Again, a small probability, but given the rules of the road that we'll see in 215, that's not that unlikely that we'll say that the supervisor is actually fudging and using age to fire people. Okay. Alright, here's another example. I suggest very strongly that you try this one yourself without watching my answers first. Alright, in a class of 16 business seniors, there are 10 finance majors. Right, so that we have 6 non-finance. 3 students come to the professor's office hour one day, and so find the probabilities. The probability that the first is finance, second is finance, and the third is non-finance. And part B, find the probability of 2 of the 3 are finance majors. Okay, so suggest you pause the video, try these, and then restart to watch the answers. Alright, so the answer to the first one, we have a given sequence order. The first is finance, the second is finance, and the third is the non-finance. Okay, first is finance. Well, we have a total of 16 students. There are 10 finance majors, so the probability of the first one is actually pretty high, 10 out of 16. Then we have 15 students left, and the probability of that the second is finance, assuming that these students are different, they don't come back. Alright, so we have 9 finance left, so 9/15ths. And then we have 14 students left, non-finance. There are 6 non-finance. They haven't been chosen yet, so that is it. Alright, so 10 times 9 times 6 divided by 16 times 15 times 14. Alright, and if I remember correctly, the answer to that is 0.1607. Alright, and then the answer to part B, probability of 2 finance in 3, again, you should know how this works by now. Number of ways times the probability of one way, since the order is not specified. How many ways? 2 out of 3. Right. Again, we've seen that quite a few times before. It's 3 ways. Probability of one way. Well, part A gives you one way. Okay. Alright, and so the answer to that is 0.4821. Okay, so that's that problem. Alright, here's a final example in these videos. For these type of problems, this example, beware, it could be either with or without replacement. Alright, the idea is that you figure that out.